Welcome back to my series of doing simple programming tasks. It seems the project Euler problems might be simple to program, but they actually touch on not quite so simple math concepts, and so does this one. This problem asks for something that is called the least common multiple, or LCM, of a range of numbers. Such least common multiples are useful because such numbers can easily be divided in many different ways. All of us are familiar with an hour having 60 minutes, and 60 is the least common multiple of the numbers 2, 3, 4, 5 and 6. That makes it easy to divide an hour into halves or quarters or thirds or fifths or sixths. This problem asks for the least common multiple of all integers up to 20. I will try two different ways of calculating this. First, the brute force method, which will be simple and certainly work, but will as usual be inefficient. Secondly, I will take advantage of certain mathematical connections to calculate the least common multiple much more efficiently. So let's start by creating an empty Python file. So the first approach will be to go through all the numbers and stop at the first number that is a multiple of everything. This can be pretty fast if we find something fast, but if there is nothing early on, then this could take a very long time. We can check if something is a multiple by using the modulo operator. If the remainder is 0, then it was a multiple. And we can do this for all the numbers they are requesting, in this case 1 to 10 or 1 to 20. It doesn't take many lines of code to run through all the numbers, but it will not be very fast. As usual, let's time the program so that we can see exactly how slow it is. And then we create an infinite loop which we break out of as soon as we find something. And after the loop, we just print the results. So program done, time to see how long it takes and what the result is. I'm starting with the example problem just to verify that everything works. And since my loop was actually infinite, I need to fix this first. So let's increase the number in every iteration. So, as you can see, it worked. It returned the right number, 2520. The time it took was about 2 milliseconds. So let's try the real problem, the least common multiple of 20. This could take a little bit longer. Or much longer. We can let it run in the background, but let's do this the right way. To calculate the least common multiple in an intelligent way, we take advantage of an algorithm that is very old. So let me show the formula on the Wikipedia page for least common multiple. So the idea is to use the greatest common divider. So the algorithm I'm going to use is that you get the least common multiple of two numbers by multiplying them and then dividing by the greatest common divider. The greatest common divider is the largest number that divides both numbers. So you can divide both 18 and 12 by 6. So the greatest common divider there is 6 because there is no bigger number. Oh, the program is done. It took like 2 minutes. I guess I will have to add some elevator music to this before I publish it. I'm implementing a greatest common divider by using Euclid's algorithm from the ancient Greeks. The algorithm is very ingenious, where you can find the greatest common divisor by repeatedly dividing and replacing the original big numbers with remainders. That way, quickly getting smaller and smaller numbers and finally getting the greatest common divisor. That is an interesting concept of itself, and maybe I should do another video just about the maths here. But I wanted this to be about programming. Just checking that it seems to work. Running Python interactively and importing your script and then calling functions manually can be a very good way to test your program. So greatest common divisor of 2 and 3 is 1, and greatest common divisor of 2 and 4 is 2. Okay, this looks right. Oh yeah, and checking that this seems to work backwards as well. I just checked with the small first number and the big second number. I need to be sure it works both ways. And it seems to do. So now we have GCD, so now we can write the program, a program that just loops over all the numbers. And let us clean up and remove some of the previous code as well. We don't want it around to distract us. And back to the loop. So the idea is that in every iteration of the loop, we look at the new number, we figure out the GCD of it and the previous solution, and we multiply the previous solution and the new number, and then we divide by the GCD. So let's try this with the example first, the numbers 1 to 10. And we get 2520 again, and this time it didn't take enough time to even show. And if we try this with 20, we see that it's also very fast. And the return value 230 million, just like last time. That's a very large number, so it's not strange that it took a long time to find it just by trying every number. So that was all for this. Welcome back to the next video where I will probably look at another project Euler problem.